2, 3, 4, 5, 6, 7, 8.
Hello folks, fellow YouTubers, friends. Got a little treat for you. There's Scott Brown. He's up here in Louisville in our shop, Boomtown Laboratories. In another clip, I showed you where we were turning the rotor, not the rotor, but the stators down with a lathe, and we messed up two stators by accidentally running the lathe in too close and it scraped the wire. So then in another video I show you where we're putting a piece of plexiglass inside, and then we turn it down, that way we don't mess up any copper wire until where the magnets will fit in. Well, Scott come up with a really good idea here. The wire in those ceiling fans is such a small diameter, like schedule 40 or 45.
A lot of resistance.
So yeah, a lot of resistance. So anyway, what he's done is he cut the wire out of one of the messed up stators, and we've got some what is that, 18 gauge, Scott?
Yeah, this is 18 gauge.
Yeah, so Scott is rewinding by hand one of the stators with 18 gauge wire. We're hoping to get a lot more amperage out of it. But anyway, it's still a little experiment we're trying. I'm going to turn the camera off now, let him get a little bit further along. Wait a minute, before I do, Scott, hold it up like you did a while ago so I can see it. Can you see that, folks? Let me zoom in. That is one neat job. Scott Brown's got some daggone patience, man. Alright folks, we'll make another clip later and let you know how it's going.
How about a tubes?
Okay folks, Scott's already got the first set of coils wound. Everything looks good, the whole 9 yards. And that only took 30 to 40 minutes for the first set. Well, the second set is the same number of coils, so we figured another 30 to 40 minutes, and we're going to have the whole thing wound up. And Scott and I got to talking about it. Those special magnets that I bought, neodymiums that were 2 inch by 1 inch by 3/8, they should go in there pretty good, and they pull 58 pounds a piece. Whoa, we're going to get some killer watts out of this sucker. Alright, talk to you later.
Okay, here's the main thing when you do this, is if you take your finger right here, you can bend this to where it's going straight out and keep it straight. And don't scrape these two pieces of metal, because that'll take the enamel off the wire. Take it over here, top side I use my thumb, pull me out some slack, do the same thing on the bottom, get it in there. And when you go on your last winding of the last coil, you want to have that come out as far to the back as possible. I'm going to have to do this one more wrap to get it where I want it. There we go. And take it in here. One more try. There we go. Now it's all the way to the back. The reason being is when I go to this next coil, if I got it pulled from over here and it stretches across, then I can't get any wire in. So this last one has to be over here. And you notice this one is going this way and the next one is going this way. On some fans you'll see a coil here, then you'll see a coil here, and the space in between that would look like that. So you'd have an odd number of coils. You definitely know. All of those coils that are separated like that with a gap in between, to say they're all rolling this way, and then it just goes over to the next one like that. Say if I got 20 turns here and 20 turns here, when I do, if you're doing it all on one section, then you wind up at 40 here because you have this room for 40 wires in here, and the next coil over here would be 40. Then when they do them like this, alternating in directions, it's 20 here, 20 here, 20 here. On your real ceiling fans, you're doing probably about 300 turns because that wire is so thin. That thin wire has a lot of resistance. Voltage divided by resistance will tell you your amps. A lot of ceiling fan, wind turbines, and alternators don't put out many amps because of that thin wire. And how long that thin wire is puts a lot of resistance in it, like 100 ohms. If you got 12 volts divided by 100 ohms, well, yeah, you're going to have milliamps. But we're putting this 18 gauge wire on here, And I'm pretty sure I'm going to have right about 6 ohms or less. You see how I'm doing this? And the other thing is these little plastic pieces here, right here, that's to keep this wire from digging into the edge here and shorting out. You got to check that all the way through. Make sure that you're not scratching the wire or pulling it up against this. You just be shorting it out and not doing yourself any good. But with this 18 gauge, and I've got 2 sets of coils, it's like better than having 14 gauge. We're going to be able to get some amps out of this one. This is a rare thing for a ceiling fan motor. A lot of people have asked me to, have I ever rewound one? Well, I've split the coils and rewound 1 or 2, but I just never did them on video. So it's really not that hard, and it actually goes pretty fast. I did the whole inside section in about 40 minutes. And this one out here, I think I'm doing a little bit faster, seeing as I don't have to go down such a deep, narrow gap without scraping. There we go. Just lay it right down the middle and don't hit anything. And you don't have to fill this up. It's not really all that hard, because when you're pulling here, you're pulling it tight and it's all staying to the side and out of the way. Before you go to your next coil, if you want to, you can take a screwdriver or something and try not to scratch the wire. Just go ahead and push it down. Take your screwdriver, make sure the end's clean. Stick it down on the flat side, not on the sharp, and just push all that stuff over. Don't worry about it. Now, seeing as I'm going around this way, I'm going to continue going around this way. I got to get rid of this piece, which I don't know why they put them in a ceiling fan motor. They say, well, centrifugal force might push the wire out. Well, I don't think so. The stator doesn't move. It's the magnet rotor that moves. So that's really unneeded. The tension of the wire will hold it right in there. There we are. Just keep on going. So if I've got 0.6 ohms with 12 volts, well, I'm pretty sure I'm going to be able to see quite a bit of amps. It'd be a lot better, a lot more efficient. As a matter of fact, I've got a Harley Davidson alternator sitting over here that's built just like a ceiling fan. The magnets spin on the outside of the stator. The stator stays still and the stator is on the inside. And it really does put out. With a hand spin, a while ago we saw 5 amps. No problem. And that was just, and it's a 3-phase setup instead of a 2-phase. But we saw 5 amps. This is 18 gauge wire. What's inside that Harley Davidson alternator, couldn't tell. It's either 14 or it's 16. So really not that much difference. There we are. And that one's basically set up. So you can see it goes pretty quick. And just flatten it out a little bit. And the next one. So anybody can do this. You just got to make sure you're not folding these edges over and pulling this wire up against the steel. Just keep it inside these plastics. Whoop. I got that sitting all the way to the outside. I need it on the inside. There we go. Put it back in again. Yeah, now it's inside instead of over here. It makes it easy to wind my next coil. And this is the last one. I don't know how many turns. I haven't even counted. Let me count this one. That should be 2 and 3 and 4 and 5, 6, 7, 8. The windings that I took off here, I counted the windings. It was over 300 windings.
Just 9.
And 10. Have I folded it over? Yep, I got one folded over. Just folded it over. Just take one winding off here. And I think I can get that Flip this out. I've done this about 4 times so far. It just doesn't feel right when I come up there. I think I'm getting used to it now. Did I get it right? Good. That'll hold it over and keep it from folding in. Alright, we're back at 10. $11, 12. Looks like 13 is going to be about it for this one. So if I had 13 for each of these, and I've got, say, 1, 2, 3, 4, 5,
14.
6, 7, 8, 9, 10, 11, 12, 13, 14. I've got 14 coils and 14 more coils, and I would say I've got 13 on each of them. You do the math, and that's quite a bit. Anyway, the last of this I'm going to wind up and fix her up. This is going to take a lot more RPMs.
13 times 14, 182.
182. And double that because we got 2 sets of coils. Well, when you got 300 coils as compared to 13, you're going to see quite a bit of difference in the RPMs per volt. But this will, the regular ceiling fan, I was powering on the AC side, taking one wire from this set of coils to one wire of this set of coils, putting them together, and then taking the 2 outputs, and I was powering 24 strands of LED Christmas lights. So
how many lights per
that's
strand?
not bad. It was, I think it was 70 lights per strand, which isn't bad.
No shit.
So, so anyway, well, we're not looking at higher voltage. We're trying to get down to where it'll charge a 12-volt battery. This is going to take quite a bit more RPMs.
That's 1,680 LEDs.
Yeah. So this is going to take more RPMs to get to the voltage, but the amps are going to be readily available. With 0.6 ohms and another 0.6 ohms, you put them in parallel and you're going to wind up getting 0.3 ohms. And your battery is about 0.6 ohms, so matching the impedance or the resistance gives it maximum power transfer. Now this is an alternator that you won't forget. When Boomer's done putting all the neodymium magnets on this, you're going to see an output that you haven't seen from a ceiling fan alternator on YouTube so far. And sorry, I've been telling people, you know, hey, just go ahead and change the windings. It's not really all that hard. You saw me do it here. I went like 3 or 4 coils right here, just going blah, blah, blah. Sit down, relax, and pull your wire and do it. It's really not that hard. Just don't short it out against the Stator material. It's real easy to do. And good luck to you. Hope you enjoy it, and be waiting for Boomer's results. Many good things to you and yours. I'm Scott Brown, Green Wind and Other Home Energies, and Raymond Head, Boomer, Boomtown Laboratories, in Lewis, by gosh, Texas.